Welcome to the Unit 5 test review walkthrough. We are going to go ahead and get started. So for number 1, the first thing I did was simplify the inside parentheses. So 2 over 6 changes to 1 over 3. And if I do x to the power of negative 2 minus negative 7, that becomes x to the power of 5. And y to the power of 3 minus negative 1 becomes y to the power of 4. Now that I have my inside parentheses simplified, I went ahead and distributed the exponent of negative 2 to every single term inside of the parentheses. Now, remember, a negative exponent tells you that the term is in the wrong position. So I do need to arrange some things. So I'm going to have my 3 to the negative 2 moves up to the top. The 2 becomes positive. Similarly, for 1 to the negative 2, it moves to the bottom, becomes positive. X to the negative 10 moves to the bottom, becomes positive. Y to the negative 8 moves to the bottom and becomes positive. The last and final step is to distribute any exponents that you can. So 3 squared does become 9, and 1 squared is just 1, so we don't have to write that, but the x to the 10th and the y to the 8th stays in the denominator. For number 2, remember this is something you have to be very careful with. The rule does not change the base. Yes, I'm going to add the exponents, but I'm not going to do anything to that base 3a. So 2 over 3 plus 4 over 3 becomes 6 over 3, which is 2. And the last step is to distribute this 2 to both the 3 and to the a. So it's going to give me 9a squared. For number 3, we are going to go ahead and multiply first. So I have some simplification. I went ahead and did 12 over 4, which became 3 and 1, and 6 over 9, which became 2 and 3. Did some multiplication. I got 3 times 2 is 6, a to the fourth, b to the negative 2 times b squared cancels out, and 3 times 1 is 3. A times a to the fifth, we add our exponents. That's going to give me a to the sixth. B to the negative 1 is just going to stay the same for now. The last couple of steps is going to require some simplification. 6 over 3 becomes 2. 4 minus 6 is a to the power of negative 2. And remember, again, negative exponents tell me it's in the wrong position, so I need to move the a squared to the denominator and the b to the numerator. For number 4, we are going to set up an equation that searches for height. So all I did was multiply both sides by 2 and then divide by b. So height should be equivalent to 2a over b. I'm going to plug in what I know. So I have 260 a to the 12th b squared all over 12a cubed b. And again, a little bit of simplification. My 2 and my 12 become 1 and 6. And then I get 12 minus 3 is a9. 2 minus 1 is just b. And 60 over 6 is going to simplify to be 10, a9, b. Moving on to 5.2, where we are solving with exponents. So we should be solving for x. So the first thing you want to make sure you have is that both bases on either side are the same. So currently I have 5 and I have 25. Now I know that I can rewrite 25 so that it's 5 squared. So that's kind of your goal when you're approaching these problems. Try to find a similar base or the same base for both sides. So now that I rewrote 5 squared, remember a power to a power is multiplication. So it's going to be 2 times x minus 2. You have to be really careful that you distribute that to both terms. A lot of the times the second term gets forgotten. But now that I have the same base, 5 and 5, and I'm saying that they're equal to each other, that means my exponents should be equal to each other. So that's going to give me x minus 5 is equal to 2x minus 4. With a little bit of solving, you should end up with x is equal to negative 1. Now for number 6, it's going to follow a similar method. I have 3 and I have 9, but I know that I can rewrite 9 as 3 squared. Now, when I get this simplification, because remember, bases are the same, I'm saying they're equal to, therefore my exponents should be equal to each other, I run into a little bit of a different solving problem. It's not going to be one of the straightforward problems where we just move terms around. Anytime you see a squared, an x, and a number, your brain should automatically be going to factoring. So I moved all of my terms to one side and I noticed that I have a GCF of 2. Going to pull my GCF out and I'm left with x squared minus x minus 6. Now, anytime your a value is equal to 1, you can use the shortcut. So all you have to do is think of numbers that multiply to be -6, add to be -1, and your two factors should be x plus 2, x minus 3. And anytime you're solving, you have to go ahead and set each factor equal to 0. So I'm going to get x is equal to -2 and x is equal to 3. Now, number 7 is slightly different because I do not have both terms in the same position. So I do have a term in a numerator and a term in a denominator. So first, let's think of, can I rewrite 32 so that it has a base of 2? Which, yes, I can. One of the more popular ones we've discussed, 1 over 2 to the power of 5. But remember, I do have my property of negative exponents where if I write this as 2 to the -5, it's still equivalent to 1 over 2 to the 5th. Now, both bases are the same. I'm saying they're equal to each other, so I have to say my exponents are equal to each other, and I get my final answer of x equals 0. For number 8, I'm following a similar method. However, this time I do have to rewrite both sides of my equation. I have 1 over 3 cubed to the power of x plus 2, 3 to the power of 4 to the power of 2. So I'm going to first rewrite my 3 to the 1 over 3 cubed as 3 to the power of -3. And remember, anytime I have power to a power, I multiply. So this right side becomes 3 to the 8th. And then I do a little bit of simplification. -3 distributes to x plus 2. And remember, it distributes to the plus 2 as well, leaving me with -3x minus 6 is equal to 8. If I do a little solving, I should get x is equal to -14 over 3. Now, for lessons 5.3 and 5.4, you can think of them as rational exponents, or you could use properties of radicals to simplify. Either way works. If I were to take the cube root of 27, that would be 3. If I were to see how many times does 3 go into 6, that gives me 2, meaning 2 x's come out, giving me x squared. And 3 goes into 12 4 times, meaning 4 y's come out, giving me y to the power of 4. Now, for number 10, I do have 8x to the 6th to the power of 2 over 3. Remember, a rational exponent, the denominator is the root and the numerator is the power. So I went ahead and rewrote this in radical form only because I know that I can easily take the cube root of 8 and then square it. I don't want to have to square everything inside and think of it that way. How you approach it is completely up to you. So I end up with the cube root of 8 is 2, and 3 goes into 6 2 times, giving me x squared, all to the power of 2. And this 2 is going to distribute to everything, giving me 4x to the power of 4. Now for 11, similar method. I am going to think of this as a cube root of 64a to the power of 9b to the power of 12. If you just want to distribute this 1/3 and deal with it as fractions, totally okay. Cube root of 64 is going to be 4. 3 goes into 9 3 times, and 3 goes into 12 4 times. So I end up with 4a cubed b to the power of 4. For number 12, I'm going to simplify my parentheses first, giving me 3, because cube root of 27 is 3, and 3 goes into 9 3 times, a cubed. And again, I have a squared outside, so I'm going to make sure that I distribute it to both terms inside, giving me 9a to the power of 6. Okay, now moving on to 5.4. So the first thing I'm going to do is I'm going to rewrite 40 as 4 times 10. And the reason why I do that is because I want to take out as many perfect squares as I possibly can. And when I do that, I get a 2 comes out because the square root of 4 is 2. And additionally, I have, if there's no number there, remember that this is a square root. So this is a 2 here. 2 goes into 5 twice with 1 left over, and 2 goes into 3 once with 1 left over. And my final step is to multiply my two numbers together to give me 4m squared p square root of 10mp. Now for number 14, this time I'm dealing with a cube root, and I have to think of what factors of 54 I have. And I thought of 27 and 2 because I know that I can take the cube root of 27. And when I get my simplification, cube root of 27 becomes 3. And then the 2 is going to have to stay inside. X squared is also going to have to stay inside because 3 cannot go into 2. And then 3 goes into 6 twice, which is why 2 y's came out. And 3 goes into 11 three times with 2 left over. So don't forget to also keep it very clear to you, especially in your writing, that this is z cubed and the cube root of. A lot of times one of these just happens to disappear. Always double check your work, leaving me with negative 6y squared z cubed cube root of 2x squared z squared. Now, for these remaining problems, this is where I mean you should not have any decimal answers. We are looking for simplified radical form. So, first thing I'm going to go through and do is simplify all of these radicals. So, I know that I can rewrite 50 as 25 times 2, 72 as 36 times 2, and 32 as 16 times 2. The reason why I like to do that is because a 5 is going to come out, a 6 is going to come out, and a 4 is going to come out, leaving me with the same radical. And in order to add and subtract, we have to have the same radical in every single term. So I have square root of 2 in all three terms. Once I have that, I can go ahead and just do the addition and subtraction of the coefficients. So 15 minus 12 plus 24 is going to give me 27 square roots of 2. For number 16, I am doing something similar, but this time I'm looking for perfect cubes or anything to the power of 3. So I went ahead and rewrote 54 as 27 times 2, 16 as 8 times 2, and 128 as 64 times 2. Went ahead and did some simplification. A 3 came out, a 2 came out, and a 4 came out. Multiplied my coefficients to give me 3, 4, and 20. All of my radicals are the same, cube roots of 2, so I can just look at the coefficients and see negative 13 cube root of 2. For 17 and 18, it's going to require some distribution. So this square root of 6 is going to distribute to both of these terms. Remember, we multiply the outside times the outside, inside times the inside. So the outside is a 1 here, so we're really not changing much there. So I get 3 square roots of 12, because 6 times 2 is 12. 7 square roots of 18, because 6 times 3 is 18. Now, again, you're always going to want to try to simplify completely. And I know 12 can be broken down into 4 and 3. 18 can be broken down into 9 and 2, which gives me 3 times 2 square roots of 3 plus 7 times 3 square roots of 2. Now, this is a problem where we're not going to get one single term as our final answer. And the reason why that is because I have a square root of 3 and I have a square root of 2. There's no way I can combine those two together. They have to stay separate because of the fact that I am doing addition. Now for number 18, we are going to be distributing. So we're going to FOIL. Firsts, outsides, insides, lasts. So I went ahead and did my first round of distributing. Square root of 3 times square root of 3 becomes square root of 9. Square root of 3 times negative 2 square roots of 3, negative 5 times square root of 3, and negative 5 times negative 2 is positive 10. Now, square root of 9 does simplify to be 3, And then I can say minus 2 minus 5 is negative 7 square roots of 3 plus 10. Now, the reason why I was able to combine these two terms together was because they have the same radical. Now, all I have to do is combine 10 and 3 to give me 13 minus 7 square roots of 3. Remember, you also have your notes to review. You have your practices to review. There are the extra practice on quizzes available, as well as your quiz that you took prior to this test. So make sure you're reviewing everything completely because everything is fair game when it comes to the test.